Hello. So this is block 10 notes. Um, on this homework, you're going to be matching the standard form, which are the red tiles, the factored form, which are the white tiles with its matching graph. Now we're doing a very, very basic intro to graphing quadratics. Quadratics means it's to a power of 2. So make sure you realize that quadratics means it's a power of 2, where the x is actually specifically to a power of 2. So things like y equals x squared, y equals negative 2x squared plus 5x minus 6. Those are example of quadratic functions, or what we call parabolas. So we're not going to go into too many details here because, again, I just want you to get an idea of a very basic idea of what this looks like. When your a is positive, your parabola is smiling. It's like, yay, we're about to go on vacation. When a is negative, your parabola is going down. It's like, oh man, I got some homework I have to get done before I go on vacation. So the first thing you want to do is always take a look. Is this parabola going up or down? Well, since a in this particular case, a is always a number in front of x squared. Since a is negative 5, that tells you that your parabola is going down. Okay. The next thing you always want to do is look, do they have anything in common? That's called a greatest common factor. Do they have anything in common? Well, I noticed that the negative 5x squared and the 10x, they both divide by 5, and they both have an x. When it starts with a negative, you always want to factor out a negative. So what's left when I divide by negative 5x? Well, negative 5 divided by negative 5 is 1. X squared divided by x is x. 10 divided by negative 5 is negative 2. And x divided by x, they cross out. So the next thing you want to do is you want to set your factors equal to 0. Factors are what you broke apart here. So the negative 5x equals to 0, and the x minus 2 equals 0. So if you add 2, x equals 2. And if you divide by negative 5, x equals 0. That means if I go on the x-axis to 0 and on the x-axis to 2, I would find my x-intercepts. So x equals 0, when you set your factors equals to 0, that helps you find your x-intercept. So now that I know what my x-intercepts are, and now that I know it's going upside down, I'm just going to go ahead and connect those 2 points by making a parabola that goes up. Okay, so the second quadratic that we're going to talk about is when you have difference of squares. So difference means minus, and squares means that both terms are perfect squares, such as 1, 4, 9, 16, 49, 100, 400, x squared, y squared. Those are all examples of perfect squares. I missed a bunch, but I'm just giving you some examples. So before we continue on, the first thing you want to do is notice that this is y equals a positive. And because it's y equals a positive, this is smiling and going, whoo, we're about to go on vacation. Okay. So difference of squares, I have 2 parentheses. And I asked myself, what times what makes this very first term, which is 16x squared? So what times what? They have to be exactly the same. So 8 times 2 is 16, but they're not the same. Perfect squares means they have to be able to be written as what squared. So 4x times 4x is 16x squared. And what times what makes 25? It's 5 times 5. And one sign is always positive and one sign is always negative. Now that I factor this, the next thing I want to do is I want to set my factors equal to 0. So if I set my factors equal to 0, I'm going to set 4x plus 5 equal to 0, and I'm going to set 4x minus 5 equal to 0. The reason why I'm setting my factors equal to 0 and then solving is because I would like to know where it crosses the x-axis. So one of my x-intercepts is going to cross when x is 5 over 4, and another one of my x-intercepts is going to cross when x is equal to negative 5 over 4. So 5 over 4 is between 1 and 2, and negative 5 over 4 is between negative 1 and negative 2. And because I know it's going up, I'm just going to connect them so it's smiling. Again, it's just a basic sketch. I'm not making this perfect. I just want to get an idea what this looks like. So let's take a look at the next one. Y equals x squared minus 4x plus 4. So I notice it's y equals a positive, and because it's y equals a positive, again, it's all smiles. It's like it's a beautiful day outside. Let's take a minute and enjoy it. So anytime I have a trinomial, tri like 3, there's multiple ways of doing this. This is the way I do it. I always draw a big X, and I multiply the very first number with the very last number, and I put it on top of the big X. And then I always put the middle number in the bottom. And I ask myself, what times what equals 4x squared? And adds to negative 4x. So again, what times what makes 4x squared and adds to negative 4x? And that happens to be negative 2x times negative 2x. So now that I have my factors, I want to rewrite this. I'm going to rewrite this from 3 terms to 4 terms. So I drop my first term, and I drop my last term. But I'm rewriting the middles. Instead of negative 4x, I'm rewriting it as negative 2x and negative 2x. It still makes negative 4x. I'm just rewriting it. So now that I have 4 terms, I want to factor by grouping. I'm going to put the first 2 together and ask what they have in common that I can factor out. I'm going to put the last 2 together, and I'm going to ask what they have in common and what can I be left behind. So x squared minus 2x, they both have an x in common. And when I factor out an x or divide by x, I'm left with x minus 2. Now, anytime it starts with a negative, you have to factor out a negative. So what does negative 2x and 4 have in common? They both have a negative 2. They both divide by negative 2. And they're left with x minus 2. Now, these parentheses, what they have in common should be the same. If they're not the same, you did something wrong. So outside, I have an x minus 2. And what they have in common that was left in the parentheses is x minus 2. Do you notice how both of those are the same? Some people would write that as y equals the quantity of x minus 2 squared. So if I were to set this equal to 0, I get x equals 2. That means that my quadratic function, my parabola, is crossing the x-axis at x equals 2. Now, unlike the other problems, I only have 1 point, and that's at x equals 2. But I know it's going up, so it's smiling, so I'm just going to go ahead and draw a parabola or quadratic function that's facing up. The last problem is, I know for some of you are like, what? She gave us a fraction, but we could do this. So the first thing you want to do is you always want to see what do they all have in common. Well, again, it starts with the negative. Before I even do that, it starts with the negative. So you know it's frowning because, yeah, it has to deal with fractions. But it starts with the negative. And because it starts with the negative, I want to factor out. I also notice they're all fractions. So is there a fraction that I can take out? So here, this is 2, this is 4, and this is 4 in the denominator. I always want to take out the biggest number in common, right? Well, yeah, I could technically take out a 2 because 2, 4, and 4, they all have a 2 in common. But when it comes to common denominators, you don't actually take out the greatest common factor, you take out the common denominator. So the common denominator is 4. And because the common denominator is 4, then I can take out that negative 1/4. So let's see what's left. Okay. Well, remember that factoring by negative 1/4 means that you're dividing, right? So I want to divide each one of these 3 terms by negative 1/4. So negative 1/2 divided by negative 1/4 is the same as negative 1/2 times negative 4, which is negative 4 over 2, which is negative 2, right? Actually, it was negative divided by negative. It should have been a positive. So this is 2x squared. And if I kept doing the same thing here, I'd get negative 5. And if I did the same thing on the last one, I would get positive 3. So I want to go ahead and I want to leave that negative 1/4 on the outside. And silly me forgot to make extra room. Let me see if I can add more space. Here we go. So y equals a negative 1/4. And I want to go ahead and do the x method with all the 3 terms inside. So I'm going to multiply the first term times the last term, and I get 6x squared. And the middle term is negative 5x. So I'm going to ask myself, what times what makes, so again, what times what makes 6x squared? And those same values add to negative 5x. So that happens to be negative 3x and negative 2x. Be careful because sometimes our brain thinks negative 5 and 1. So I'm going to rewrite this. I drop the first term, which is 2x squared. Oops. Then I rewrite the middles. Instead of negative 5x, it's negative 3x and negative 2x, and I drop the last term. So what do the first two have in common that I can factor out, and what do the last two have in common that I can factor out? Well, the first two, they have an x in common, and I'm left with 2x minus 3. The second two, notice it starts with a negative, but they don't have any number in common except for 1. So they have a negative 1 in common, and what's left is 2x minus 3. So I still have a negative 1/4 on the outside, but now my other factors are x minus 1 and 2x minus 3. Don't worry, you don't have a bunch of problems like this. I know it's a little bit of a challenge. See, if I set my factors equal to 0, you can't set negative 1/4 equal to 0, so that's not a factor that would help us find our x-intercept. So x minus 1 equals 0. So x equals 1. And 2x minus 3 equals 0. So x equals 3 halves. So now that I know where my quadratic function intersects the x-intercepts, I'm going to look for an x-intercept at 1 and an x-intercept at 3 halves. So 3 halves is between 1 and 2. And my parabola has to go upside down because it started with a negative. So again, these are just basic introductions. You want to use some of your clues to help you figure out which matches with which. And I encourage you to do all the easy ones first. Have a fantastic vacation, and I will see you back after Thanksgiving break.